Okay, let's dive in. Welcome, everyone. We're tackling something really crucial in cancer care today. It's not just about which treatments get used. It's about the order they're given in and the impact. Well, it's massive for patient health, yes, but also for healthcare costs. We're basing this on a really interesting new study. It's called Modeling Cost-Effectiveness Analysis of Treatment Sequencing, led by Professor L. Robin Keller over at UC Irvine, co-author with Jiaru and Cristina del Campo, just came out in Socio-Economic Planning Sciences. So our goal here, let's unpack what they found, using their modeling techniques, their data, to figure out, what are the best treatment paths.
Yeah, and what's really striking, I think, is how this research shifts the perspective. We usually look at treatments almost, well, in isolation, right? But they're analyzing the sequence, the order you deliver them. They use these quite sophisticated cost-effectiveness models, simulations based on real-world data. Think of it as like running thousands of scenarios on a computer, predicting outcomes, predicting costs, sometimes years down the line for different sequences. And the aim is pretty clear. Find the sequences that, give patients the best shot, but are also, frankly, smarter economically.
And the findings really jump out, don't they? The
Yeah.
sequence makes a huge difference. That's what they found. This is where it gets really fascinating for me. They showed that specific orders, whether it's chemo first or targeted therapy or immunotherapy, lead to just completely different results. Can you maybe give an example they pointed to?
Absolutely. So for certain types of cancer, they found that starting with a targeted therapy, then moving to immunotherapy, well, that showed significantly better survival rates, much better than other orders. Professor Keller really stresses this point. It's not just about mixing therapies together. It's the timing. The specific order, that's what really counts. If you get that sequence right, you might actually create a kind of synergy. Maybe make the later treatments work better, or perhaps reduce the chance the cancer develops resistance.
Huh. So using that targeted therapy first, it could sort of prime the patient's system, make the immunotherapy more effective when it comes later. And if you just flip that order around, maybe it wouldn't work as well, less effective.
Exactly right. Their modeling showed pretty clearly that reversing that specific sequence often led to, well, diminishing returns. The treatments just weren't as effective. And that obviously leads to poorer patient outcomes. And crucially, that links directly to higher costs over the long run, because if a treatment isn't working well, you need longer treatment, or the disease progresses sooner, or you end up needing more expensive therapies later on.
Wow. So getting the order wrong isn't just potentially worse for the patient's health, it really hits the healthcare budget hard too. Okay, so what does this mean practically? For doctors, for hospitals, for policymakers who are always juggling tight budgets?
Oh, the implications are pretty big. For both clinical practice and how resources get allocated, by actually identifying these cost-effective sequences, doctors can make, more informed decisions. They can discuss not just which drug to use, but crucially when to use it to really maximize the benefit for the patient. And for the health systems, the payers, this research gives them a data-driven approach, a way to potentially refine treatment guidelines, make sure that the money, the resources are going towards pathways that are proven, both clinically effective and economically sound. It's really about getting the most value, both in health terms and financial terms.
Making care more sustainable. That feels incredibly important right now. Where does the research go next? What's the future direction here?
Well, this study provides a really strong framework, right? But the authors themselves say, look, we need to apply the sequencing analysis much more broadly, more cancer types, different patient populations. And very importantly, they highlight the huge potential for integrating personalized medicine into these models.
Okay. So not just sequencing based on the type of cancer, but tailoring the sequence based on the individual. Things like their specific genetic makeup, maybe how their particular tumor is likely to respond.
Precisely. That's the next frontier. Bringing in genetic markers, other biomarkers, that allows for much, much more refined predictions within these sequencing models. So if you know a patient's genetics suggest they'll respond really well to, say, drug A, that might influence where drug A fits in their optimal sequence. For maximum impact, minimum downstream cost, it's really seen as a vital step towards truly personalized, truly optimized cancer treatment.
Okay, so the main takeaway seems crystal clear. Strategically planning the sequence of therapies. It's absolutely critical, not just for better health outcomes, but for building a healthcare system that's actually sustainable, that's cost-effective. And the future is about weaving this sequence strategy together with very specific, personalized patient data.
Which really leaves us with a big question, doesn't it?
It really does. Given how powerful this sequencing effect seems to be, how might focusing really intently on the order of therapies fundamentally reshape things, not just personalized cancer care itself, but maybe the whole economic structure of healthcare down the road. Definitely something to think about.